all done that. You guys need to move yourself, so you can move yourself. You good?
All right, Alden, take it away.
Hello, my name is Alden Richter, and I'm here to present on experiments with quarks, which we learned about in our lab this summer. So today I'm going to talk about two ways we experimented. One is the Millikan oil drop method, and the other one is GlueX, specifically with the Tagger microscope. So first is the Millikan oil drop method. In 1908, Robert Millikan started his work with Harvey Fletcher to try to find the elementary charge, which is extremely important to physics because it's the integer charge that we use every day. And he planned to do this using the charges inducted to oil drops by the nozzle of the sprayer. So, that's not right.
Or just use the arrow keys.
Yeah. So the theory behind it was oil drops could be suspended in a chamber by the electric field produced by these two parallel plates here. The field created by the plates pushes up on the oil drop against gravity. And when it pushes up, it causes the oil drop to levitate. So in order to find the charge of the drop, you need to find the force of gravity so you can set the two equal. So in order to find the force of gravity, you first need to find the mass. And the way we do that is by first finding the radius using Stokes' law, and then using Stokes' law for the force of drag. After you find the radius, you can find the volume, and then multiply the volume by the density of the oil drop, which is known. Then you can set the weight equal to the electric force. So this is the apparatus we used. It has a sprayer, a chamber, two plates, a viewing microscope, a light bulb, and an adjustable photometer. So the way we do it is we spray oil drops into this chamber. The oil drops fall between the plates, and the experimenter will switch on the plates to try to find a charged oil drop. After they do that, they allow the oil drop to fall to find its terminal velocity due to gravity. Then they use Stokes' theorem and the volume equation to find its mass and its weight. And then they can set its weight equal to the electric force on the drop. After they've done that, they can divide by the electric field caused by the plates, and they can find the charge of the drop. So we conducted the experiment ourselves. As you can see, there isn't a lot to tell. Typically, we would be searching for quarks in between these spikes, but our results were not precise enough to search for quarks. So to remedy this, GlueX is working with a Tagger microscope to find quarks in a bit more drastic way. So Suki was talking about these exotic mesons, which we don't know if they exist, but if we do find one, we'd like to be able to recreate it so that we can confirm that it is in fact real. So the way they're created is by sending energy at a hadron and pulling on one of the quarks until the amount of energy in the quark and the gluon creates new quarks and new mesons. So in order to recreate this process again, to get the same exotic mesons that we're hopefully going to observe, we need to know the energy of the photons. Measuring the energy of a photon directly will then change its energy, so we need to find a way that will measure the energy of a photon without doing it directly, so by some other means. And the Tagger microscope is what we're planning on using. So this is how the microscope works. Electrons are shot towards this little diamond wafer here. As they go through the wafer, they experience bremsstrahlung radiation, which is, as they pass the atoms in the wafer, they're curved by the electric field. So they decelerate and emit photons. They're then pulled by this magnet into scintillating fibers, which will measure their resulting energies, and the photons are allowed to travel into the big detector. Since all of the electrons are shot with the same energy, if you find their energy here after they've been curved and emitted their photon, you can subtract that from their original energy and find the energy of the photon they sent. So that helps us because then we've measured the energy of the photon, we haven't changed the energy of the photon, and we can recreate the mesons in here. So by measuring the energy of the curved electron, the energy of the photon can be found and recorded, and we can recreate any exotic mesons we happen to stumble upon.
Is there a reason we use oil rather than some other substance?
I don't think so. I think it's easily charged, and it's a liquid, so it works with a sprayer. So.
Why do you, how do you get the quartz from the charged electron, charged oil?
Oh. So, as Omar was saying, the quarks have non-integer charges, whereas the oil would have integer charges because of the induction from the sprayer. So what we were looking for was outliers in our data that would have these tiny little, like 1/3 charges, but we weren't precise enough to, is that